Hello guys, in today's video we'll do a small comparison of an analog meter to a normal digital meter because still a lot of people like them and I wanted to check them out. The multimeter that we'll be talking about today is Proskit MT2017. It's a DC and AC voltmeter, null meter. I will show you what a null meter is. Ohm meter with a buzzer, battery tester, and DC ammeter. Pretty nice device. Small little mirror on the scale. It has a lot of scales that we can discuss. So it's a pretty simple thing. On analog meter, we nearly every time have ohms scale, volt amp scale here, and here we have some additional scales, which is microfarad scale. I wouldn't measure capacitors with it though. Null DC voltmeter, so you can see that we have 0 in the middle, and to the left we have minus, and to the right we have plus. Battery tester, which just shows us if the battery is good or bad. Then we have the HFA meter with a socket here for testing LEDs and NPN and PNP transistors. It shows us the HFA of a transistor and the collector emitter leakage current, or it can be a current of tested LED. Then it shows down there linear voltage, which is pretty misleading, but it is just the threshold voltage of the LED or the diode that we plug in here. And then we have the decibel meter that I wouldn't use, and here we have the add what kind of value we need to add on different scales of the AC voltmeter in order to measure dB values. Here we have the input impedance of the meter, which is 20 kilo ohms per volt on DC and 9 kilo ohms per volt on AC. It's the standard value for analog meters on the DC scale, and it's a pretty low value on AC. It is fuse and diode protected. The range between here and here, which is the standard volt, milliamp, and ohm socket, is protected with half an amp fuse, and with 10 amp fuse, the 10 amp socket is protected. So we have different scales here. What needs to be noted there is that we have a small little scale there, which is common for low current and low voltage measurement. So here we have 100 millivolts full scale and 50 microamp full scale here. So we can measure both voltage and current on the smallest scale. It just connects the input directly to the movement. Here we have the 0 ohm adjust knob, and that's how it basically looks like. So let's measure some simple voltage with it. Let's switch it to 50 volt scale, and we have 12 volt on our power supply. The needle goes up, and we can see that, that's my face, if I will point exactly the voltmeter, you can see that it shows nearly 12 volts, a bit more than that. So how to measure it? We have 50 volts scale, full scale, so we take the values that are in this middle row. And in the middle row here we have 10 volts, and here we have 20 volts, and in the middle of them we have 10 divisions. So in the middle here we have 15 volts, and here every division is 1 volt. So we have 11 and 12 volts, so it shows us a bit more than 12 volts. So let's right now measure a bit lower voltage. Let's, for example, measure 9 volts right now. So on this scale, it is not very accurate. It shows a bit less than 10 volts. But if I will switch to 10 volt scale, we can see that it shows us a bit more than 9 volts. It's within the specs, you know, because it has 3% tolerance on DC scales. So it's okay, in my opinion. So let's right now measure some lower voltage, which is like, for example, 2 volts. Let's measure something like 2 volts. Right now we've got 2 volts, and on low scale you can see that the precisement of the measurement is a bit low. Why? Because we have like 2.2 shown there, but we have a lower range that we can use, and on the lower range we see that it's a bit more than 2 volts actually, and this is when the disadvantage of the analog meter shows up, that exact 2 volts there are shown by my power supply like 1.9 volts. So this is the disadvantage of this meter. It's pretty inaccurate. It has like 3% tolerance. So that's the biggest disadvantage of it, of the analog meter. So let's compare other functions of it. So when it comes to resistance, or maybe let's try the null DC voltmeter. So on a null DC voltmeter, I switch to it, you can see that we've got the hand roughly in the middle. I need to tune it with 0 ohm adjust thing. And right now I will set my bench power supply to 5 volts. And right now I will connect it in reverse. So I have connected in reverse. Let's do 25 volt range. And what we can see here is that we've got this range here, 0 volts, and it shows us minus 5 volts because the polarity is in reverse, minus 5 volts. You can see it here, minus 5 volts. And if I will connect the polarity the right way, so the minus to minus and the plus to plus, you can see that we've got plus 5 volts. And right now, if we know the polarity that we have connected ourselves the right way around, we can set it to 10 volt scale and measure precisely if it is 5 volts. And we can see that it's nearly 5 volts within the specs of this meter. So this is what null DC voltmeter is. It can show you the polarity, or it can show you how the values are changing in respect to 0 volts. So let's right now do resistance. Very big advantage of this meter is very fast buzzer. The buzzer is faster than on nearly all of the meters that I got. Very fast, as you can see. It doesn't have latch, so it can squeak a bit, as you can hear, scratch a bit, but it's okay. We've got the battery test. Battery test is very rough. So for example, here I have a normal AA battery, connect the polarity right, and it shows me that the battery is just good. On those 2 bars we have the red bar is bad, then the good bar, and it just shows us if the battery is good or bad. It loads the battery with internal resistor, so it is not just the voltage of the battery measured, but also the current. So it just shows us if the overall voltage and current characteristic of the battery is okay, and if it is okay, it shows us this. So let's right now do some resistance measurements. Of course, if you know, the analog meter needs to be calibrated every time you measure the resistance. On different scales, it puts different series resistors, and you can see that it has different batteries and then can be trained out differently, so we need to compensate for all of that and your leads at the same time with the 0 ohm adjust knob. This just needs to be done every time. So let's right now measure 200k ohm resistors in series. So they will be 100k, so I will put it on times 1k scale, zero it out like that, and right now put one lead in the middle, and on the other resistor 10k, nearly 10k, as you can see shown on this range. I am measuring it like that, 10k, on the other resistor on the other side, bang on 10k, and both of these should be 20k, and they are 20k. So right now, another disadvantage of analog meter. Let's measure some voltage divider voltages. So I will set my power supply to 10 volts and I will connect it to this 10K voltage divider. Across it there is 10K. So right now I am on 10 volt DC scale. So on 10 volt DC scale we've got the lowest possible here numbers. So right now I am measuring the voltage across the whole divider. It's nearly 10 volts, that's okay. But in the middle it's like 4.8 volts, it's not 5 volts. And why? Because it puts in parallel to this one of these resistors that I'm measuring here, it puts in series to it 20k per volt. So here you have 10 times 20k, it's 200k ohm resistor in series, in parallel to the resistor that we're measuring right now. So that's why it is not bang on 5 volts. It doesn't have FET input, so it doesn't have voltage follower circuits on the input. In order to compensate for that, it just loads your circuit with this resistance. So another thing that we can measure is LEDs with this. For measuring LEDs, we use this scale, which is labeled HFA and LED, and we are using, as I told you, this LI and LV range and scale. So here we have 3 volts, as you can see on this lower scale, and here, and it starts from right to left, and here it starts from left to right, and here we have the current of the LED, and here we have the voltage. So let's compensate it, short the probes, tune it to 0, and right now we can put an LED into the socket. So let me put, for example, a red LED. Just put it in, it shines and it shows us that it's the voltage across the LED is somewhere around 2.4 volts and the current through it is somewhere around 3 milliamps, which is kind of okay. That's how it should be. We can also put here some infrared LEDs, for example like this one. This is an infrared LED. The current through it is much higher and much lower voltage. So here we have 1.1 volt and the current of roughly 9.5 milliamps through it. And of course you are not able to see how it shines because it's infrared. Then we have normal silicon diode like this one. We can put it in with the right polarity, and it shows us that the voltage drop across it is pretty low. It's like 0.2, maybe a bit closer to 3 volts, 0.3 volts. So it's a pretty versatile multimeter. It can measure different values. When it comes to capacitance, I need to grab a capacitor. For example, I will use a 10 microfarad capacitor. It is measured on this scale, 1K times 1K resistance scale. Again, compensate for it a bit, and you connect the leads, those probe leads, to your capacitor, but in reverse polarity. And you are not able to see it. It's a 10 microfarad capacitor, so I will connect it in reverse, and the needle should jump to nearly 10 microfarad, and it jumped somewhere around here, and here we have 10 microfarad on the capacitance scale. So it is a 10 microfarad capacitor, but I wouldn't use this range for measuring stuff like that. So when it comes to AC volts, it can normally handle mains voltage. I can and it shows us some kind of voltage. In this case it is 200, 250 we've got there. In the middle we have 225. One needle is 5, so 225, 230, nearly 235. So that's the mains voltage, as you can see there. So here I've got a 230 volt mains frequency transformer that has 24 volt AC output, but it's not exactly 24 volts, so we can test it with our meter if it is exactly 24 volts or it's a bit less or a bit more. So I put it on 50 volt AC scale, put it a bit closer to the camera, and right now measure the voltage. And the voltage across this transformer is, on this scale we've got 1 volt per division, so it's 25, 26, 27, 28 volts AC. And it is okay because this transformer is not exactly 24 volts. So the overall experience of using an analog meter in 21st century is a bit strange because they don't offer so big reliability as your digital ones, but they still can be very nicely used to measure current and some DC and maybe AC voltages, and it's much simpler. Sometimes you just want to use an analog meter, and that's what those meters can be used for. When it comes to this meter, they have pretty low tolerance because this one has 3%, so it's not a very precise meter. And as you can see inside here, we've got fuses, 2 AA batteries, and this is another disadvantage of those meters, is that they use 2 types of batteries in order to use this one, in order to use this null DC meter, and some of the resistance ranges it uses 2 AA batteries and 1 9 volt here. I will show you this in a second. Here it got a 9 volt battery. So that's basically all that I can tell you about analog meters. I will try to use this meter in some of a few next episodes in order to show you if it is still useful in the lab. The biggest advantage of it is that it can be positioned like that, and it can be tilted slightly like that. It has 2 types of it, and this tilt stand also can be a hang-on stand. So see you guys in the next video, where I will try to use this meter in action.